Hello, hello there, people. We still have 1 or 2 minutes. If anyone has to go to the bathroom real urgently, now is the time. It's down the hall. If you need to restock on drinks, I'll wait 2 more minutes. Should we start? Are we ready? Is that food still hitting you, or are we good? Nice. Well, welcome everyone. I'm actually quite excited to be back in Copenhagen. It's been a number of years. I think it's been 7 years since I've last did a presentation in Copenhagen. So I'm quite excited. It's a great place. It's like, no offense, hipsterville. So I like it. I like it. Also, shout out to the front row people. I'm a front row kind of guy myself. I always enjoy it. Now, I've used this imagery that is a little bit of a wink wink to Mission Impossible because we're trying to cache the uncacheable today. And you'll see throughout the session that we're going to build up the level of complexity or the things we want to achieve that go beyond the regular caching logic. And I hope you could bear with me. But before I actually kick this off, I want to do a little bit of an intro and I want to do a little bit of a spot check here with the crowd to see if we're on the same page. Because what are we doing if we're not on the same page? I've done this, I think this is my 295th presentation. I've done this more than 100 times, and I typically do this through 3 distinct statements that I present to the audience to see if they agree or don't agree. And this happens in a very vocal, crowd participation style way. So if you're a fan of that, it's going to be great. If you're not a fan of that, don't worry, we're among friends. Just do what you do, look on your phone or whatever. So are we ready for those 3 statements? All right. Okay, good. Statement number 1. I'm going to stand a little bit closer to see how that works. Do we agree that slow websites suck? All right, that's good. It's a pretty good audience. Statement number 2, also an easy one. Do we agree that web performance is an essential part of the user experience? Third one, slightly more controversial in my opinion. Do we agree that a website that is slow is just as bad as a website that is down? Yeah, I'm meh. I see a lot of meh as well when I do this. Well, regardless of your yes, no, or meh, the statements I'm going to make don't really care about their opinion. These are just, I wouldn't call them facts, but they occur quite a bit. If your website is slow or it is down, you lose money, you lose face, might even lose a little bit of Google PageRank. The question is, what do we do? How do we tackle this? And a lot of people look at this symptomatically. Oh, your website is slow or your system is slow, it's probably related to capacity. So we need to add capacity and throw servers at the problem. A lot of people do that, and while it's not a sustainable solution in the long run, because you're just spending money on symptoms rather than looking for root causes, in the short term, it is good, because if there's a fire, you need to do firefighting. So adding temporary capacity is not a bad thing. But as the famous poet, Notorious B.I.G. once said, more money, more servers, more problems. So it's not really the best possible solution, is it? So what do you do is the second time I'm asking this question, what is the solution? Some people would say, why don't you identify the slowest parts and optimize? And I'm a big fan of that. It's very sensible. You optimize, you look at the full stack, going all the way from the data center all the way up to your application code and anything in between, from operating system to physical tuning on your server to your application stack, your code, your database, your external APIs, whatever, or at least the things you are within your domain of responsibility. And while that makes sense and you'll get decent gains, you'll hit the point of so-called diminishing returns after a while, where your growth projection and the amount of money you put in and the expectations you have don't really balance out that well. You just hit the limitations. So the third and last time I'm going to ask the question, what do you do? My answer is like a sort of a door number 3, could be caching. I'm not saying this is the definitive solution, but it is the topic of my presentation. So I'm trying to convince you that caching could solve part of the problem. I use the analogy of boxes often when I refer to caching, because caching is nothing more than storing pre-computed results in boxes for later use. And I won't play in the game with you, but I'll just give you the outcome. Sometimes I ask people, what's 2 + 2? And then they say 4 real quickly. And then I ask them, did you compute that or did you cache that? And then turns out they cached that. So that being said, hi everyone, my name is Thijs. You hear maybe by my accent that I'm not a native speaker. I'm a Dutch-speaking Belgian. I'm the tech evangelist at a company called Varnish Software. And I'm available on social media if you want to reach me afterwards, or if you want to heckle me in real time now, that's within the possibilities. I'm the author of Getting Started with Varnish Cache, which is the first book I wrote. It was a tremendous opportunity, writing via O'Reilly, beautiful, but that's the outdated book. I have a new one called Varnish 6 by Example, featured right here. I'm going to raffle this copy at the end of the presentation, so if anyone's interested, we'll find a way to give it to you. It's actually my lockdown project. You remember that stuff, right? That happened in 2020, all the way up until what, 2022? I had tons of time on my hands, and I wrote a book, and in a year and a half, I thought I wrote my book in Markdown, and then used some tools to push it into like a Word document that the editor printed. I thought I was writing a 300-pager. Turns out, at least I thought, I was writing a 500-pager. But then when you apply the layout of the editor, it's a 778-pager. So the lockdown lasted way too long. But if you want, you can get a copy of this. A lot of the stuff I talk about and a ton of other things are featured in it. So it's good if you're interested. If you rather have, or if you're not the one that won it and you're interested, we have a free online version of this that you can look at. Now, by show of hands, I'm always interested in that because it's also part of my responsibilities as an evangelist to check who's heard of Varnish software before by show of hands. That's quite good. That's quite good because a lot of people know us as the company behind the Varnish Cache project. And a lot of people know Varnish Cache without necessarily being aware that there's a company behind it. Not only do we support the open source project, we also built the enterprise version that tackles issues that go way beyond what typical users have, like typical big organizations, like their support and advanced features and what have you. The total ecosystem that we manage, which includes enterprise and open source, spans about 10 million active websites, 22% of the top 10,000. And apparently more than 10 million people already downloaded the Docker image to play around with. So if you take all that information and you ask me, so what is it that you guys do? Yes, we make the web faster. That's what we do as a web acceleration company. But it might be to your surprise that we also enhance digital experiences, which is a bit of a marketing buzz term, right? By lowering network latency. So what does that actually mean? We also build content delivery software. So you can use that caching software to build private CDNs, which is a surprisingly big market. It caught me off guard when I joined the company. So we build software defined, which is the emphasis here. We don't offer it as a service. We give you the software to build your own web acceleration and content delivery solutions, fitting all into that nice life without latency marketing term. Now, the only thing I want to do before we actually kick it off and go into the nitty-gritty is throw in one number to show that we're serious about performance. So this is the result of a benchmark that Intel did on their latest generation of CPUs called the Sapphire Rapids generation of CPUs. They wanted to do a little bit of a benchmark for different kinds of software, and we fell in the category of content delivery workloads. And they wanted to see what they could do with a highly optimized system, which they partnered with us, and discover the upper bounds. And for now, and this is the published number, we can do 1.3 terabits per second on a single machine. It's a 2U server. We're looking at publishing results at what you can do with a 1U server. So for now, this is the fastest content delivery technology on the planet, with the emphasis on for now. There's always a race. Netflix pops up every now and then being faster, but for now, this is the number, 1.3 terabits per second. We're hoping to go way beyond that anytime soon. But another interesting number is the one next to here. If you disregard the growth and performance point of view and solely focus on sustainability, which is in big part the ecological aspect, of course, but also just sustainability in general, running a sustainable business, trying to eliminate costs where possible, then we can do 1.17 gigabits per second on a single machine per watt. So it's all part of the story, doing more with less. And that's just the performance numbers. A lot of people don't need these numbers, but I just wanted to show you what we do on a daily basis and that we have clients that really care about this. Now let's talk about stuff that might be relevant to you guys. Now, a normal interaction pattern between a user and the server is a pretty direct one. Users tend to connect to an application server to get the features they want. And that's pretty normal, but then when a lot of users pop up and they have very compute-intensive tasks that they request, then the server is under pressure. The way we tackle this and the way our caching solution works, and other caching solutions that call themselves reverse caching proxies, there's a whole range of them, they typically place themselves in front of that application server performing so-called origin shielding. Meaning that they take in all the requests. If they have the version that is requested, they'll serve it without even talking to the origin web server. But if something is not in cache or has expired, it fetches that. Does that make sense to you? Well, I still see some confused faces, and for that I always throw in this one. And I also give it a couple of seconds to sink in. So what are we looking at? A movie, right? Who's old enough to have seen this movie? What's the name of the movie, ladies and gentlemen? The Bodyguard. Let's continue. Featuring, and yes, we have a pretty mature audience here. Kevin Costner, Whitney Houston. I'm not sure if that makes sense to the youngsters here in the room, but it's a movie I saw when I was pretty small, and it's about a very popular artist played by the late Whitney Houston. Who, and I use that as a sort of an analogy for the web application, right? It's very talented, feature-rich, if you will, and it provides a service to the audience. But the audience is so excited, they get a bit creepy at times, and there's tons of them, and the fans are stalky. So the application, in this case Whitney, needs protection, and that's where Kevin Costner comes in. Kevin Costner is the strong bodyguard that protects Whitney Houston from all these stalky fans. So Kevin is Varnish, and Whitney is the application. So when in doubt about reverse caching proxy, think about Kevin and Whitney. Now, if you apply this into the real world and you want to start using this, does that mean you have to throw everything overboard and start from scratch and build this into your architecture? Luckily, the answer is no. And that's because it's all about HTTP. HTTP is the protocol that seems to be dominating our space, and we speak HTTP as well. And you might notice, or you might not notice, that HTTP has built-in caching mechanisms into the protocol, which make things a lot easier. For you, as who considers him or herself a developer here? Yeah, most people, yeah. It gives you the sense of developer empowerment, where you as a developer can control the outcome and control how caching happens. So let me throw in a couple of examples. This shouldn't be very foreign. Cache control header, part of HTTP spec. How long will this be cached for if you look at this? It's very quiet. 500 seconds, indeed, thank you. And because of its public keyword, it means that both the client can cache it. Remember, browser caching uses the same syntax, and shared devices such as Varnish. Let's up the ante just a little bit and throw this one in. How long will Varnish cache? I'm just going to wait until I hear something out loud. It isn't. It isn't. I knew that would be throwing or making sure that it's a bit more difficult. The answer is 1,000 seconds. Varnish will cache this for 1,000 seconds because it gives precedence, the priority, to this Smax directive. And who remembers this famous quote in IT? It's by a guy named Phil Carlton. There's only two hard things in IT. Remember what they are? Cache invalidation and naming things, exactly. And the naming things is, well, this is a caching talk, not an invalidation talk. That's a whole different story that I could talk about the next time. But the naming things already starts messing things up. Look at the syntax. Max-h. S-max-h. It's a bit off, right? Yes? HTTP. This is HTTP. This is just HTTP's cache control header. And according to the spec, which we adopt, and which I assume other products in that space adopt as well, is S stands for shared. So all the shared devices should apply this value first. And if that smaxh value doesn't apply, then it takes the max h. Which means if you apply the max h of 1,000, the browser is supposed to respect the max h. Meaning the browser is allowed to cache it, unless you force the cache of the browser, of course, for 500 seconds, whereas we, as the cache, we cache it for 1,000 seconds. So that adds a little bit more complexity. What about this one? Well, I'm not going to play the part where I ask you what it is. It's pretty obvious, right? We don't cache. If Varnish sees private, no cache, or no store, either of those statements, it won't cache. But of course, each of these directives has a separate meaning. Private means you are allowed to cache, but only if you're the client. So it means as soon as a proxy in between sees private, it doesn't cache at all. Surprisingly, again, and it's again that naming things statement, no cache doesn't mean you can't cache. No cache means you cannot serve it from the cache without doing a revalidation with the origin. So if you have it in cache, you could serve it, but you need to check first if it's the latest, which isn't that efficient. And no store means don't store it in the cache. Those are three different meanings, but in the end, towards the type of cache that we operate, it's pretty much the same thing. Who's heard of vary? Vary is an interesting one. It's a cache variation mechanism saying to the cache, look, if you store this in cache, make sure you have sub-objects of that object. So how do you, anyone have an idea how you identify an object in any type of HTTP cache? What would you use to identify an object? The URL would be a good start, right? If we look at RESTful context, right, the resource is identified, is the uniform resource locator or identifier, that part. But since we work in multi-tenant systems that host multiple websites, the host header also plays its part. So you have the host header and the URI that are used to create a hash that identifies an object in the cache. What this vary header does is it says add the value of the accept language header as well, along with maybe some other headers. And I know it sounds confusing, that's why I drew up this diagram for you to make life a little bit easier. So when the user sends a request, it does a GET request for the homepage, for example.com, but its browser is in English. So the accept language header that the browser emits contains EN. Varnish knows this, sends the request to the origin. The origin responds with, okay, here's payload, 200 okay. Cache control public max h 500, so we're going to store it in the cache for 500 seconds. But please create a cache variation on accept language, meaning it will have the sub-object with EN, and maybe I'm Dutch speaking, we have an NL version and a Danish version and a Swedish version, and that way you can ensure that multilingual websites, for example, that leverage that header can still be cached. Or other headers like accept encoding for clients that don't support gzip encoding, or as I showed you in the slide before, X-forwarded proto. Maybe you have a TLS proxy sitting in front of Varnish, terminating the TLS. And if it came that way, it means it's HTTPS. So that X-forwarded proto value would be HTTPS. If it comes in directly to Varnish or under plain HTTP, it would be HTTP. And in order not to break the URLs, because they matter, you can store an HTTP and an HTTPS version. And any valid request header you can think of, you can vary on. Does that make sense? Sense enough to go to the next one? Right. Here's another header. This is the last one that I wanted to show you that you can use. There's plenty more, but what this does is it caches it for 500 seconds. But if the cache expires, if that 500-second counter has elapsed, then a cache should normally send, upon the next request, a backend fetch, and the user has to wait until the response comes back. Thanks to stale while revalidate, for the next 200 seconds after expiration, you can still serve old stuff while you do an asynchronous revalidation with the origin. That way you don't penalize the origin for certain slow content. So it's tolerated staleness, and it's also part of the spec, and I would highly advise you to use it. So that being said, with all these things put into place, I'd like to mention that Varnish reflects those specific standards and respects them. It complies to the HTTP standard conventions. And while that's very easy to apply on imagery, CSS, JavaScript, static HTML files, there's no real difficulty there. Things start getting more interesting when we venture into the world of cookies. Now, who shares this common hatred of cookies just like myself? A lot of people, yeah. But we have to deal with them. There's nothing we can do. What I can say, and you can see it in that little text balloon over there, as soon as Varnish sees a cookie, it doesn't cache by default. And that also applies to authorization headers coming in. And that is not a limitation in Varnish, it's actually a feature, because typically it's too dangerous to assume that you can cache, because it's content for your eyes only. And there have been plenty of examples where people set the cache too aggressive. I did it in my time. I remember putting the cache too aggressive, and we started caching shopping cart data. So people started logging in, seeing someone else's shopping carts. I've heard this famous story where tax returns were cached, and everyone could see this one person's tax returns. Pretty bad. So that's why we're very cautious by default, and that's the emphasis here, by default. And as soon as we see a cookie, we don't cache. Which requires me to halt this presentation and stop it to a screeching halt and reflect on that. So I'm going to present a statement again. I'm going to ask you a question, and together we're going to come to a conclusion. The statement that I would like to reiterate is, Varnish does not cache when cookies are present. Statement. Question to you. Do you know any modern websites that don't use cookies? Conclusion. Varnish cannot be used in the real world. Would be the initial conclusion, right? And the answer, of course, is no. Because I've used the word by default to cover my bases. What you can do in Varnish, and that's one of the core features, and that's what's made me fall in love with Varnish back in 2010, is we have this built-in programming language called the Varnish Configuration Language, or VCL. And it allows you to extend the standard behavior. Standard behavior such as cookie comes in, no caching. You can tune that to your behavior and to the behavior of the application. So that VCL language actually allows you to interface with request handling, reroute requests to wherever they need to be routed, manipulate any type of response coming in from the backend, selecting which backend you connect to. Maybe you have a multitude of backend servers you connect to. Choose those. Controlling every aspect of the cache, and then finally making decisions on the edge. And you'll hear that throughout this presentation, on the edge. Now, the edge represents the outer tier of your web platform. It's services that typically interface with the users. And those take in a lot of traffic, a lot of requests, and caches are typically those edge devices. So are CDNs. But CDNs are nothing more than caches distributed globally as a service. Just wanted to put that out there. VCL is a domain-specific language, meaning it has no other applications except Varnish. It has a typical curly braces style. I'll throw in a ton of code examples in a minute. And it gets transpiled into C at startup, and that C code gets compiled into a shared object, which is linked to the Varnish runtime. Makes it super fast, super flexible. It's not a language that you have to define all your logic in a top-down way. There is a standard behavior. You just extend the behavior where you don't like the standards. And that happens through a finite state machine where you hook into it. And this is the finite state machine. When I do Varnish workshops, like these 3-hour workshops, full-day workshops, I typically spend half an hour drilling it into your brains. But we don't have that kind of time. So I'm going to quickly go over it. The boxes that you see represented by those squares or those rectangular shapes are states. And they represent specific parts of the Varnish engine. They all start with VCL underscore, and then they have a short name. The first one you see here, going from start all the way up left, is VCL rec v, which stands for receive. And that's the logic that is executed when it receives a request. The little arrows that you see in the different colors, those are the actions you can take within a specific state that would allow you to go to the next. So if you receive a request and you deem it cacheable, you follow the green arrows. So you create the hash and you enter in VCL hash, where that URL and that host header is used to compile a hash. You look it up in the cache, and then it's either a hit, which is the green line, a miss, which is the blue line, or a forced cache bypass, which is the red line. And then you have others as well. So these things should make sense when you talk about caching. So if we follow the green path, you receive the request, It's deemed cacheable because of preconditions. There's no cookies, no authorization headers. It's a GET request. You create the hash, look it up in cache. It's a hit. You go to VCL hit, you deliver to the client, end of story. But when you have a hit and the content has expired, then you go to miss, and miss follows the blue line. Blue is not bad. Like a miss is a hit that just hasn't happened yet. And then you go into that big gray box, and as soon as you go into the gray box, that's where you do connections with the origin, with your backend server. Our goal in this presentation is to keep that to a minimum, because it's typically quite sensitive to heavy traffic, heavy load. So that's the finite state machine you can extend. I know your anticipation. You want to see a code example. Here it goes. Here's the first one. Here's how we could deal with cookies. It's a very rudimentary approach. So the syntax is in VCL syntax 4.1, has no relationship to the version of Varnish. I think Varnish is at 7.3 if I'm not mistaken. This is the latest and greatest VCL syntax 4.1. We've introduced these version markers to deal with compatibility. Then you define a backend, which happens to be on the same machine. If your environment's big enough, you probably have separate nodes for Varnish, separate backend servers. But in this case, the web server is at port 8080. Then we start hooking into that famous finite state machine. We're hooking into VCL receive, which is the part when we receive the request. If we receive the request, we're looking at the URL property of the request object. So what's the URL of whatever we got in? If it matches the following regular expression, then we take an action. The regular expression, which is used with the operator, the tilde operator, indicating this is a regex. If it's /admin or a subordinate resource, it means you're in very personalized territory. You probably don't want to cache it. So you do return pass. And under all other circumstances, you trim off the cookies because you don't need them, ensuring that Varnish could cache it. So within the finite state machine, this is where we're at. We're at the pass level. We're doing return pass. You end up in pass. You always bypass the cache and look things up in the cache. You can do more. You can hook into VCL backend response. Just for reference, where's VCL backend response? It's all the way down there. It is when you first went into the big gray box. You did a fetch first, which means you sent a request to your origin because something wasn't stored in cache, because of a miss or a bypass. And as soon as the backend responds, prior to storing that object in the cache, that's when you hit VCL backend response. So let's go back to the code. What we're trying to do here is override the time to live. If the backend response object has an HTTP header called content type, which is usually the case, right? HTTP responses have content types. If that matches image or video and then a slash, then obviously we're dealing with an image or video. And that's very static, and we want to cache it as long as possible, so we override the TTL to a year. So even if you throw in those cache control headers, we'll completely ignore them, bump it to a year, and even override the cache control header that might have been set already for the client, so that the client caches it for a year as well. If it's not an image or a video, but a plain HTML file or a JSON response, then we'll cache it for an hour, just to show you that you can hook into these parts. So remember, we're hooking into that type of business. Let's throw in some ugly code, right? We all like a little bit of ugly code. Here it is. Oof, a lot of it. Ugly regular expression. This is what I'm trying to eliminate in Varnish piece by piece. We've done it in the enterprise version already with good modules. We still have a little bit of work in open source. Rexup all and Rexup are very popular. It's regular expression substitutions. It's find and replace using regular expressions. What we're doing in this logic, luckily I annotated it with comments, is we're trying to optimize the URL. We're trying to sanitize it, because lesson number 1 we learned in security, don't trust the client, don't trust the user. First thing we do is we do alphabetic sorting of the query string parameters. Because everything's a string, right? You identify objects in the cache using the URL. If you reorder query string arguments like ID equals 1 and lang equals dk, if you switch them up, it's a different string, it's a cache miss. So we alphabetically sort them. If you're in the marketing business, you use a lot of probably Google Analytics campaign codes. Those add no value whatsoever to the server, and they cause cache misses because the values change, and it's pretty much the same resource but with extra annotations. We trim them off. We don't need them because the JavaScript code that Google Analytics uses will treat those. And then in the end, if you have these hashes that you use for HTML anchors to navigate through elements on the page, those add no value to the server either. Trim them off. And if your URL ends with a question mark, it means you probably tried to add query string parameters, but you didn't. Trim that off as well. And that hooks into this little thing. Now let's apply the logic we've applied so far to the wonderful world of cookies. We already did it. Let me go back a little bit to this code. So how do we deal with cookies? We trim them off unless we're in the admin page. Let's try a different approach where URLs don't matter anymore. Here we go. Another ugly one. But don't worry, I got your back. I'm going to show a prettier piece of code later on. What we're doing here is identifying whether there's a cookie. Because remember, Varnish doesn't cache by default if there's cookies. What we're doing with these regular expressions is actually removing every single cookie except that pattern, which is PHP session ID. So if you have a session ID cookie, it means you're probably logged in and you don't want to start caching. So in the end, we remove every cookie except that one. And if the result, and that's that last if, is a collection of white space characters, then you probably don't need cookies. This means that everything is cacheable until you log in. It's a very sensible thing, and the Drupals and the WordPresses of this world typically use this. But cookies aren't necessarily evil. I'm giving them a bad rep based on what I'm saying. But you can actually leverage them to create custom cache variations. Hence this example. Same deal. Remove every single cookie except the language cookie. Because in this context, we're in a multilingual website where you typically go, you remember, right? You go to the splash page, you select your region, you save it once, and then your language gets stored in that cookie and is used throughout the website. What we're doing here is removing every single cookie for the backend except the language cookie. And even though there is a language cookie, we're not going to bypass the cache. We're going to force the cache by doing return hash. So we're saying even though there is a cookie, we still want to cache. But not just like that, not just with every URL. What we want to do is we want to create custom cache variations based on the language. And that's where we go into VCL hash, where we influence how the hash is created. Where the URL and the host header are still applied, we're going to add extra logic, extra hashing information by checking the cookie value and extracting the selected language as a variation. So in this case, if the cookie has content or a cookie name called language and the value is either Dutch, German, French, could add Danish there as well, then reg sub, perform a find and replace, look for the language value, which is grouped here, NL, DE, FR, take that value, which is group 1, and hash it, meaning that the language is now part of the hash. If that is not the case, you fall back to English. And that way you still have the flexibility of having a multilingual website without leveraging browser language. And with the security in there, not to create too many variations. Because if we don't explicitly define the languages we support, have you ever seen the accept language header sometimes, or language cookies? It get infinite. And if we don't validate it, people can get clever and start entering random strings. So we've now leveraged cookies to our benefit to create a multilingual website. Now, part of my mission as an evangelist is to get rid of these ugly regular expression substitutions. And while it's still a common tactic for VCL writers, I would like to convince you to go into the following territory, which is a lot more clean. There is a cookie module that has been added 1 or 2 years ago to the core of Varnish. So if you're on a recent version of Varnish, you have that module in core. You can import it, and then you have a clean interface to do the same thing. So if we look back at this, tons of ugly regular expressions. What you do now is just say cookie.keep, which means remove everything except the cookie or the lists of cookies you presented there. And then you can use cookie.get to actually extract values from cookies and create the cache variations you want. Please use cookie vmod. Okay, next up. What you've seen so far is cookies are very important to the level of personalization and segmentation of your cache. But it's usually pretty binary. Either the page is cacheable or the page is not cacheable. And that's not always fair. Especially when you're in situations where you have everything is cacheable. For example, 99% of the page is cacheable, except that little login bar up top. And as soon as that comes in, there's no caching happening because that's the common denominator. You're returning it as a single response. So how do we tackle this? We use placeholder technology. Placeholders to separate the cacheable and the non-cacheable content and do sub-requests to arrange this. You probably use this in your regular development tasks. Who can figure out a technology that is pretty common in web that does this? Any takers here? What would we use as a technology? Still with me? Still awake? A technology that probably sits in your tool belt if you're more at the front end level. I'm gonna spoil the beans here, or spill the beans rather. Yes! Ta-da! Ajax calls, right? They typically do that. You can cache the entire page, but that little stateful bit, you load it asynchronously via JavaScript, and it comes with all the benefits and the disadvantages. It's very common. A lot of people know about it. Most frameworks support it, but there's downsides to it because it's pretty much a middle finger to the client saying, look, whatever happening here is now your responsibility. You have to load this resource because we don't really want to bother. And on very poor network connections, if you have a really poor 3G or even an edge connection, God forbid, then that extra round trip will really matter. And there's ways to eliminate that. Anyone have an idea what kind of server technology we could use for that? It's an official standard, but I'm not sure if everyone is familiar with it. So I'll give it 3 seconds before I spill it. Ah, yes, there we go. We have a very well-educated audience here. Now, edge-side includes is very much like server-side includes. Who remembers server-side includes from back in the day? Yes. Similar story, right? You put a placeholder in there, in your HTML code, and you expect someone else to figure it out. And back in the day, the server figured it out. Who remembers these really ugly front-page extensions from back in the day? Similar story, right? Well, edge-side includes do the same thing, but as the name implies, on the edge, on the outer tier, in Varnish. So you can throw this into your code, which is an official standard. It was invented by Akamai, to be honest. And now a lot of frameworks, a lot of edge technologies, a lot of caches support it. We do as well. So as soon as Varnish sees this in the HTML or whatever output you use, we're going to do an ESI sub request. We're going to take that, send a request to that endpoint, header in this case, and store it separately, which gives you some really interesting benefits. So it's a placeholder, it's parsed by Varnish, but Varnish will stitch the output together and still present it as a single HTTP response. So we're not bothering the end user with, hey, go fetch this, go fetch it. No, we assemble it on the edge, and every block can have its own state and its own TTL. So if something is not cacheable, well, that Varnish will take care of that, but it will still show you whatever it has, and maybe 99% can be cached. Or if you want to have separate TTLs, it's also possible. So how do you instrument that in VCL? It's as simple as doing this. However, I'm not a big fan of doing it that way, because that means regardless of the size of the response bodies, Varnish is going to have to scan through looking for an ESI tag, which might become pretty CPU intensive after a while. So I'm a big fan of negotiation, and there's even HTTP headers for that. So what we can do is actually emit a surrogate capability header, which is again an official HTTP header, saying, look, we have ESI support. We are a surrogate, so we can act on your behalf and perform ESI. And then as an application developer, and I know some frameworks support this out of the box, you can look for that header. And if the header has the value you want, you can respond with, hey, if you have surrogate capability for ESI, I will take surrogate control. And as soon as Varnish sees that surrogate control header come back with ESI in it, it will do the processing. Like here. We emit the header saying, hey, dear backend, I'm not a regular client. I'm actually a surrogate. I'm here to fetch content, but if you give me ESI, I will know how to deal with it. And then the backend could say, fine, let's do it. And then we start parsing ESI. Some frameworks do that. It's a very logical, like sort of a handshaking way. And then as a developer or as a front-end person, you can throw this into your HTML code, knowing that something else is going to deal with that. And that something else might turn it into this. Maybe there's a session cookie, I've logged in, and then you have that placeholder. It's very efficient. If it turns out you don't have surrogate capabilities, this will be the HTML that you output server-side anyway. And it would make sense to have a little component, a view component in there. I've built certain view components for that. I come more from the PHP world where certain frameworks have that built in. And it's very easy. The fallback is if there's that little view component will do the negotiation for you. And if it's not there, it will just render it internally. Status update, ladies and gentlemen. We are 37 minutes in. Let's take a moment to reflect. Take a sip of water, which I will do now, and think about what we've done so far. We have looked into the level of personalization by removing the cookies we don't need because they're going to mess up our hit rate. For some cookies that were useful, we actually leveraged them to create cache variations. And we've realized that it doesn't always make sense to send a single response. Sometimes we want to chop things up and give things their own state, make certain things cacheable, others not. But the big lesson now, and this is where we go into the interesting bit, is that even though 99% is cacheable, that 1% could really hurt you if it receives enough traffic. Those non-cacheable routes. So the mindset we'll apply here is instead of just serving content on the edge, we might take advantage of that VCL language and do more compute, do more personalization. I'm going to throw some random ones in here just to show you. We can handle post request as well. Posts are typically not cacheable. If you look at the RESTful theory about it, if you do a post to something, it means you're probably creating a new resource, which is a state change, typically not cacheable. But in certain cases, it might make sense to cache or add the request payload to the hash. You could do that. I'm not going to elaborate on the code. You can do other stuff like rate limiting, saying, hey, under certain circumstances, I want this client to be like limited to a megabit per second, perhaps. Or we can do request throttling, where you could look at the client IP, which is stored in client identity, and allow that client to do 15 requests every 10 seconds. There's typically more logic to it. I'm just oversimplifying it. And if you exceed that, you're in the penalty box for 30 seconds. And that is denied function will deny you access. And if you've overstepped the boundaries, then we're going to return synthetic output. And you'll see that throughout the presentation. We'll be using plenty of synthetic output. The definition of synthetic output is output that we created that didn't originate from a backend fetch. So whatever we're returning, we're not storing it in the cache, we're just immediately returning it to you. And we're giving you some meta information. You're still blocked for X amount of seconds. You can do that. So security measures. We've talked about cookies quite a bit. Now it's time to talk about authentication. You can turn Varnish into an authentication gateway, pretty much taking over that task from the origin. Because if you have authentication on the origin, well, you can't cache it. So we could take over that job. This is a super insecure way. But then again, basic authentication is not that secure, right? It's just a base 64 username and password pair separated by a colon. So you could check it that way. You could say, okay, if the authorization header is other than that base 64 string, I think if you base 64 decode it, you end up with username user and password pass, I guess. And then you trim off the authorization header because remember, Varnish won't cache otherwise. And if we trigger that 401 synthetically, then we end up in VCL synth, which is the template we use to return synthetic output. We're going to attach that www authenticate header, and the browser will look for that. And if it sees that, it will show you that typical server-side pop-up. Remember that one, right? It pops up and it gives you a way to enter your credentials, which your browser will then convert into that base 64 encoded string. So far, so good, but there's more efficient ways of doing it, more flexible ways. There's a module out there in the wild, in the open, called basic auth. You have to compile it from source, unfortunately. The people who built it didn't package it. But it allows you to read the typical HT pass WD file, which web servers typically use. And it allows you to have a list of multiple users and passwords. And they support hashing as well, because you can MD5 hash your password into those HT pass WDs and pretty much replicate the same thing. Now, so far, so good. That's basic auth. But what about JWT? Who's heard of JSON Web Tokens? Majority, I would say. Well, for those of you who haven't, it's is it an authorization or an authentication mechanism? I typically ask the audiences that, and opinions tend to vary. What's the opinion here? Is it authorization, authentication? What is it? Both. I'm happy with that. We're not offending anyone. Everyone's right. Authorization, authentication. It typically consists of, or it always consists of 3 parts separated by dots. And thanks to the color coding, you can see that there's different elements. The red part is the header. The pink part is the actual payload of the token. And the blue part is the cryptographic signature that is secured with an HMAC. As such. And the HMAC, of course, has a secret key. So if we decode this, because this is nothing more than JSON encode it with base 64. If we base 64 decode it, this part ends up in that and the other. You can use your imagination, right? So the header typically dictates the type we have. It's a JSON web token. And the algorithm we use to secure it is an HMAC signature with SHA-256 as the hash. Gives you an idea on what security mechanism to use. Then, of course, you have the middle part, which has the sub, the name, the IAT, the exp. Pretty short naming conventions, right? That's because all that data has to go over the wire. So if you're wasteful with strings, it's going to be a really huge string you send over the wire. ALG and type are pretty standard naming conventions. Sub, IAT, and exp as well, and there's more. So what we're saying with sub is that's your unique identifier. That's the client ID. Name is a custom one. I add it. It's John Doe. It's the name of the user. IAT is the issued at, which is the time this was created. And exp is the expiration time. Those are Unix timestamps. Don't forget that this is public data. The user can read this themselves. Don't put any data in there that the end user is not allowed to see. It's not that secure. The only security level that is in there is to protect you from tampering. Let's say you have an expired token and you want to update the expiration time. As a user, you can do so. You can decode the JSON and fiddle with the timing and re-encode it and send it to the server and try to do privilege escalation or extend your token. Thing is, there is a cryptographic signature in there that is an HMAC with SHA-256 of your header and your payload, concatenate it with a dot, and then has a secret on top of it. So if the signature doesn't match, it means someone tampered with the data, and that's the security level you have. And the story is that Varnish can validate that. So who knows the secret key that is used for the HMAC? The one who creates the token and the one that validates the token. And in this context, we as Varnish would be the validator. How do you pass those along? You can do it with cookies on a website, but it typically happens in an API context with a bare authentication token. That's the most common thing. And now I'm going to show you the code, how to do it. Now, I would recommend that you hold on to something because the code is not the prettiest. Let's go. Boom. Let me walk you through it. Let's do some hand holding here to make sure things don't go haywire real quick. We need this digest module, which is an open module you can install, and the standard module as well. The first thing we do is check whether or not there was a bare authentication token sent, and that bare authentication token must match a regular expression, meaning some content, a dot, some more content, a dot, and then some more content. And you need three distinct parts separated by dots. If that is not the case, we're going to send a forward tree saying, hey, JSON web token required. Fair enough. That's the way you exclude a lot of abuse. But once you have a bare authentication token, you want to analyze the three different parts. So the first thing we do is grab the first group, as you can see. The first group is the header. You do a rec sub, you store that in the header. From that header, you can analyze the type, which is doing a sort of a find with a regular expression into your JSON object. And you're looking for the TYP property and grab the value. That's your algorithm, or your type at least. And for the algorithm, you do the same thing. And then you start validating. If the type you got back and the algorithm doesn't match our preconceived notions of JWT HS256, then you have an invalid header. And you stop there. So continuing along. Once you know that the header is right, we're going to look at the payload, and we're going to extract the payload, which is the second group. And we carry on. Then we grab the signature, which is the third group. So first algorithm, payload, then the signature. Then you have that signature, but we also know what the signature should be, and we can generate that. The way we generate it is by taking the header and the raw payload that we got, put it together with an HMAC signature, perform our secret key on it, which is secret, which is fortunately not so secret. And bear in mind that you probably have a rollover strategy as well, where that secret key gets changed every now and then. You can actually load that value from a file or from an API call if you want to in Varnish. But for now, it's just secret. And then you have the signature you got and the signature you expect. If they don't match, someone has been tampering with it, and then you return 403 invalid token signature. And then the final bit is easy, right? You just extract the payload, which is base64 URL decoding the payload, and get in some values from it, like the username, which you will use later on, or the expiration time. And as a final check, you can take that expiration time, convert it into a time, check if it's smaller than now. If it's smaller than now, Token is expired. Sorry, 403. So that's how you do that. Very ugly code, I admit. But that's what's out there right now. We do have an enterprise VMod, but we have no plans of open sourcing it because it's a revenue generator, unfortunately. But this is how we do it. Pretty simple, right? You import the JWT module. I'm not trying to sell this to you for all intents and purposes. I'm an evangelist, not a salesperson. I just wanted to show you that it exists. There's a module out there that does this in a clean way. Let's elaborate on that synthetic HTTP for a minute. We have 10 more minutes until I have to let you go, and I'll try to do it quicker. So this is how you do it. We've done it before, right? If you don't specify as a second argument to that synth function, if you don't specify a string, then the standard reason phrase will apply, which for 200 is okay. Good. What was it again for 404? Nice. And for 405? Good, good. We have a very HTTP savvy audience. I'm happy with that. So as soon as you throw that into the mix, some HTML is going to be returned. And unfortunately, that's the HTML you're going to get, the standard template. Again, by default, could be a bit murky, but there's always ways to override it. If you ever see a website that outputs guru meditation, you probably know it's Varnish. There's also a variant of this out there called guru mediation, not meditation, but mediation. And that's Fastly's implementation. Now remember, a couple of years ago, Fastly went down. There was an issue. Fastly's pretty big CDN. And a lot of people started calling me, Thijs, there's a problem with Varnish, there's a problem with Varnish. Until I checked the little details and I saw guru mediation, and I knew, oh, this is not us. But what you can do is get rid of this and change the template yourself. You do that by hooking into VCL Synth. And instead of doing this ugly HTML, maybe you'd want to do it plain text. Very straightforward way of doing it. But what if I told you can actually leverage those synthetic response to highly personalize the output and actually fetch stuff from certain data points? I'm going to give you an example. This is what we're going to try to do. There's an endpoint called API/session, which you'll probably use in maybe some AJAX or ESI call to populate the shopping cart. How many items are in the shopping cart? It's stateful, so you might use a bearer authentication token, or just a session cookie. We're going to use a session cookie to make sure we have less code on screen. And this part is actually going to be compiled or computed by Varnish. Typically, you can't really cache it because it's so highly personalized. So the lesson I want to teach you here is you can actually do this yourself if you want to, and make something that is uncacheable, cacheable. Assuming that this content is stored in Redis, which is a very common key value store where people store session data, you can use a module that is not developed by us, by this guy named, an awesome guy named Carlos Abalde, and compute that yourself. This is the data structure in Redis. So the session ID that we have is the name of your key in the Redis key value store. If it exists, it returns 1. If that key, which is a hash, in fact, if you do HMGet to get multiple properties from the Redis hash represented by that key, and what do we want? We want the Boolean whether or not someone is logged in and the number of items in cart. You get those values. And now we're going to reach the point where we're going to do this in Redis, pretty much caching otherwise uncacheable stuff. Here's the code. You import the Redis vmod, the cookie vmod. You're going to initialize the Redis database, which lives on that IP, on that port. Then when you receive your request for API session, instead of sending it to the backend with all the consequences that come with it, we're going to intercept it. We're going to analyze the cookie and check whether or not the session ID is set. If it's not set, 403, not allowed. If it is set, we're going to store the cookie in the session ID property and do a synthetic response, 200 OK, and let VCL Synth deal with it. Then you enter VCL Synth. We're going to intercept that request again. And then we're going to do all the Redis magic, which means checking if that key exists. If it exists, good. If it doesn't exist, meaning that the result of exists returns 0, then we're going to return a 404, which you can see here, right? We're creating an empty JSON body and synthetically returning 404. We've got that covered. When it does exist, we do HMGet and get the properties that you saw earlier, and then inject them in the body and pretty much create that ourselves. So all of this comes from Redis, which was originally highly personalized and would be very taxing on the system, all of a sudden gets done on the edge. Pretty powerful, right? And I want to mention, I'm going to go over this super quickly, that there's a lot more possibilities in Varnish Enterprise. We even have this module that does mustache template parsing on the edge. Like, familiar with mustache syntax, the handlebars, right? Well, we can turn this using that data point into that. So it's a bit more flexible than ESI. And you have code for it that would merge at delivery time for whatever we parsed, merge the data points in there. It expects it to be JSON, and then we'll deal with it. Even if you don't, your application doesn't support mustache syntax, we could do finds and replaces and turn this div into that and then handle it without even touching the code. And tons of possibilities. I'm not going to go over them. What I want to do to end this, because we have 5 more minutes, is talk about the future of all of this. So this fits into this very trendy topic called edge compute. This is clearly edge compute, but it's in a domain-specific language tailored around Varnish. And you can get tons of benefits from it. I would advise you to use it. However, I see a future where the syntax of VCL needs to be extended a bit. VCL, for reasons of not allowing the users to shoot themselves in the foot, doesn't support for loops. It doesn't have native variables. It's lacking array support. I've advocated with the core group because it's not us who built the open source project. It's a group of people, and the project lead is an independent person who actually is Danish. His name is Paul Henning Kamp. They decide on that. We have influence in there, and my goal is to ensure that a future version of Varnish, I'm not sure if it's near future or far along down the road, has more syntax to do edge compute. But in parallel, and that is something we do as a company and could end up being open sourced when it's done, is actually moving into the world of WebAssembly. WebAssembly allows you to just write something in whatever language you want and then transpile that into WebAssembly syntax, and we would then have a VM within the runtime that would process that. And we would provide a bridge to VCL, where from VCL you can call whatever you want to call. Because this is an emerging market, not just edge compute, but edge compute caches and all that kind of stuff. Doing more on the edge is big. And it's actually one of my ambitions to create a talk about this, not necessarily about WebAssembly, but about the edge, not necessarily as how you've seen now, but from an infrastructure perspective. Probably heard of AWS Wavelength. AWS now offers 5G mobile edge compute services where you're directly connected to the 5G base station. That's where I want to take this and show you that you could do really low-level, high-intensity caching stuff without even touching the application. So that's it. I see most of you are still awake. That's a good sign. I still have this book to raffle. I typically, people tend to ask questions, and then the person who answers the question right gets the book. But A, I have no idea who's actually interested in reading this. And B, I'm lazy. So what I'm going to do is I'm going to put this book here, and eventually it's going to disappear. And if it doesn't disappear, I guess I'm going to have to take it back home. Dear people of Copenhagen, it's been an absolute honor and a pleasure, and I would like to thank you for being here with me.